Alright, so today we are going to be looking at binomial expansion. So binomial expansion means that I have a binomial, meaning a factor that has two terms, and I want to raise it to a certain power. The expansion is what we get after we do that multiplication. A very quick and easy way to perform binomial expansion and get that expanded version of that binomial raised to the power is to use a method called Pascal's triangle. Pascal's triangle is named after French mathematician Blaise Pascal. You can see that he only lived to be 39 years old, but he contributed a lot to math and science. Thus, he has this triangle named after him. You can see that the first and last numbers in each of these rows is always going to be 1. Every number other than 1 is the sum of the two closest numbers in the row directly above it. For example, if the pattern starts like this: anything, no matter what it is, raised to the 0 power is 1. If I have a binomial to the first power, that's going to be just a plus b. And you can see that the coefficients are 1 and 1, and there's Pascal's triangle. If we have a binomial to the second power, it's going to end up being 1a squared plus 2ab plus 1b squared. Look at the coefficients, 1, 2, 1. If we have a plus b to the third, this was in our video notes for 4.2 part 1. Look at the coefficients, 1, 3, 3, 1. So all Pascal's triangle does is it gives us the coefficients. And here's how it's developed. It goes 1, 1, 1. I bring down this 1. 1 plus 1 is 2. Bring down that 1. Have another 1. 1 plus 2 is 3. 2 plus 1 is 3. Bring down the 1. Bring down this 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then bring down the 1. Okay, so now let's find the sixth row on our own. Okay, so our coefficients, I bring down the 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and then I bring down the 1. This will give me the coefficients if I'm trying to find a binomial to the sixth power. These will be the coefficients. Another thing to notice is in all of these, whatever this exponent is here, that's where we start. So it starts with a to the third, a to the second, a to the first, no a. With the b, it starts off b to the 0, which is just 1, so we have no b. Then b to the first, b to the second, b to the third. If we have a plus b to the fourth, look at the pattern. A to the fourth, a to the third, a to the second, a to the first, no a. No b. B to the first, b to the second, b to the third, b to the fourth. Okay, so it always is going to follow that pattern. Let's try this now. We're trying to have the binomial x plus 3. We're trying to raise it to the fourth power. So, if I was going to figure out Pascal's triangle, let's say we don't even have it. Let's say it's not up there, and I just had to do this on my own. Well, I could use Pascal's triangle to help me. I go 1, 1, 1, 1, 2, 1. I have 1, 3, 3, 1. So this is to the 0, this is to the first, to the second, to the third. This would be to the fourth. I brought down the 1, 4, 6, 4, 1. Those will be my coefficients. Because it's to the fourth power, it's going to go 1, a to the fourth, then a to the third, then a to the second, a, no a. The b's are going to go no b, b to the first, b to the second, b to the third, b to the fourth. So using all of this, if I were to expand this, it's going to be 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Look at that again. All I did was I used my coefficients, 1, 4, 6, 4, 1. I use the pattern. It's going to go A to the fourth, A to the third, A to the second, A, no A. No B. B to the first, B to the second, B to the third, B to the fourth. Now, with this, I'm just going to identify what is my A. Well, A is X. What's B? B is 3. And now it's just a matter of substituting in and figuring it out. So A was X, so we're going to have X to the fourth plus 4. Plug in A is X, cubed times B, plus 6, A squared, B squared, plus 4, A times B cubed, plus B, which is 3, to the fourth. So if I simplify this, look at my terms. They're separated by pluses and minuses. Here's plus, 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 plus. Because this is to the fourth, 1, 2, 3, 4, 5, I should have 5 terms. This was a binomial cubed, 1, 2, 3, 4 terms. Binomial squared, 1, 2, 3 terms. It's always one more. So I've got my 1 term, 2nd term, 3rd term, 4th term, 5th term. Those are my 5 terms. Figuring those out, x to the fourth plus 3 times 4 is 12x cubed plus 3 squared is 9 times 6 is 54x squared. 3 cubed is 27 times 4 is 108. X plus 3 to the fourth is 3 times 3 times 3 times 3, which is 81. There's going to be our expansion of x plus 3 to the fourth. That is much easier than doing x plus 3 times x plus 3, getting that answer, multiplying by x plus 3 again, multiplying by x plus 3 again. I'd have to multiply all that out, and then I'd have to multiply that out, and then I'd have to multiply those. Challenging to do. All right, let's take a look now at example 2. It's to the 5th power, so we're looking at a plus b to the 5th. If I had to do it on my own, let's say I didn't have all of this up here, I would have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. This is the row that I need. I now identify A and B. A is 2x. B, because the patterns have addition in between them, B has to be negative 5. So now, I'm going to write out what it would be. So this is 1, and it's to the 5th. So it's going to have to go A to the 5th, 1A to the 5th, plus 5A to the 4th, B. See how the pattern goes? A to the 5th, A to the 4th, my next one will be A to the 3rd. What's the coefficient though? 10. A to the 3rd, B to the 2nd. The next term is going to be, 10 has to be my coefficient. A to the 5, 4, 3, 2nd. B has to go up by 1, no B's. First, second, third.
Extension 10436.
Next term.
10436.
B to the fourth. And then finally, I'd have to have 1 for my coefficient, B to the 5th. Alright, let's pause for a second. Look at the pattern again. With the B's, no B. Here's my first term, second term, third term, fourth term, 5th term, 6th term. What do you notice about this exponent in the number of terms? Yeah, it's going to be 1 more, isn't it? The number of terms is always 1 more than this. This was to the 4th. 1, 2, 3, 4, 5 terms. Okay. So my first term then, I'm going to plug in my A value. I'm going to have to get a little divider here going. Now, let's use this marker. So a is 2x, so I'm going to have to plug in 2x. I'm going to have to do 2x to the 5th. That's going to be my first term. Plus 5. Plug in 2x for a. 2x to the 4th times, what's b? Negative 5. Plus, I'm on my third term. 10, find a, 2x, I have to cube it. B was negative 5. I'm going to have to square it. So I've got my 1, 2, 3 terms. I like to do this as I go. I'm down to here. 10, a is 2x. It's got to get squared. B is negative 5. It's got to get cubed. Almost there. Plus 5a. B is negative 5. It's got to go to the 4th. And then plus, last term now, negative 5 has to go to the 5th. Alright, so I need to figure all of that out. Some of this I'll know, some I may need to use a calculator on. Just have that handy if needed. Alright, 2 to the 5th, hopefully you know that. But if you don't, just a reminder, you can always do 2 raised 2. Right there's the caret, right there below clear, to the 5th power. Push enter. There's 2 to the 5th. Alright, so 2 to the 5th is 32, and then it's going to be x to the 5th. Done with that term. Go to my next term. Now my next term is going to be a positive times, anything to the 4th is positive, times a negative. So my next term is going to be negative. Might as well keep that in mind. I've got 2 to the 4th, that's 16. 16 times 25 is 5 times 5. I'm just multiplying this in the easiest order. So 16 times 25, that's going to be 400. So minus 400, x to the 4th. Done with that term. Okay, keep going. Next term. Negative 5 squared. Well, that's going to be positive, so I know it's positive there. I've got negative 5 squared is 25 times 10. That's 250. 2 to the 3rd is 8. So I'm going to have 250 times 8. So what's that going to be? 2,000, I think? Just want to double check. I don't want to write this down wrong. So what did I have? I had 250 times 8. Just double checking. 2,000. And then it's x to the 3rd. Alright, finished with that term. On to our 4th term. Negative 5 cubed. Well, that's a negative times negative times negative, so that is going to be negative. And that's 125 times 4. Let's just grab the calculator. 125 times 4 times 10. Multiplying all that, 5,000. So minus 5,000. And then our x is getting squared. Done with that term. 2 more to go. Okay, negative 5 to the 4th. That's going to be a positive answer. 5 times 5 is 25. 25 times 25 is 625. 625 times 2 is, what, 1250? 1250 times 5 is 6250. I always like to double check. $62.50. Okay, just wanted to make sure. Plus $62.50x, and then a negative raised to the 5th power is going to be negative, and 5 to the 5th. Don't really remember that. Yes, I'm a math teacher, but I don't know that one. 5 to the 5th, 3125. All right, I'll remember that from now on. 3125. All right, so here we go. This is our answer. when we expand that whole thing. I check the number of terms. This is to the 5th power. I should have 6 terms. 1, 2, 3, 4, 5, 6. That's good. My exponents on the x should go x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, no x. Looks good. All right. Now, let's look at the next one. Find the 4th term of this. Just the 4th term. Like this is the 1st term, 2nd term, 3rd term, 4th term. I'm not going to figure out this whole entire expansion when all I need is that 4th term. It's to the 6th power. I'm going to come over here and do Pascal's quickly. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That'd be to the 3rd power. This is to the 4th. This is to the 5th. And this would be to the 6th power. Make sure you got all the numbers. If it's to the 6th power, how many terms should we have? 7. 1, 2, 3, 4, 5, 6, 7. We're good. Okay, all we're trying to find is the 4th term. This, 1, 2, 3, 4, this is the coefficient of that 4th term, 20. So I know I'm going to need a 20. For the 4th term, A is going to be 3x. B is going to be negative 2y. Think about the pattern. It's going to go a to the 6th, a to the 5th, a to the 4th, a to the 3rd. So it's going to be 20a to the 3rd. With the b's, it goes no b, b to the 1st, b to the 2nd, b to the 3rd. Remember, if this is to the 6th power, these should add up to be 6. The degree of this should be 6. Okay? Back here, the exponents should have added up to be 5, and they did. Down here, they add up to be 6, and they do. Now it's just substitution. We're going to have 20. A is 3x. B is negative 2y. So we've got 20. 3 cubed is 27x cubed. This is multiplication, not subtraction. Negative 2 to the 3rd is negative 8y to the 3rd. And now I just have to multiply all of that. And so we're going to have 20 times 27. I know it's negative. I don't need to bother with the negative. Negative 4320 x cubed, y cubed. That's what that 4th term would be if I were to go through and do all that work. All right, last thing, finding the 4th term of this one. This is to the 7th power, so I need to have the 7th row. So I got to find that. I'm just going to use the one I already have. So I bring down the 1. 1 plus 6, 7. That's 21. That's 35. Oh, wait a minute. I can stop there, can't I? I only want the 4th term, so I only need to find that coefficient of the 4th one. I don't need to go any further. All right, there's my coefficient, 35. Okay, so now let's think. It's going to go 35. It would go a to the 7th, a to the 6th, a to the 5th, a to the 4th. So I'm going to need a to the 4th. Do you guys know what power b would go to? You're right, it's to the 3rd. If I didn't know that, it's going to go no b. B to the 1st, b to the 2nd, b to the 3rd. Plus, these have to add up, these exponents must add to be 7. And they are. Now I substitute in. A is 2xy. B is negative 3. Okay, so plugging all this in then, I'm going to have 35. A is 2xy to the 4th. B is negative 3 cubed. This is 35. I know 2 to the 4th. That's 16. I'm going to have x to the 4th and y to the 4th. And then I have to multiply by negative 27. Again, this is just telling me that 4th term. This is all multiplication. It's just like back up here. 1st term, 2nd term, 3rd term, 4th term. I had to multiply all that stuff together. I have to multiply all of this together. What do we get? I know it's negative. I'm not going to bother putting in the negative sign. And we get 15,120 negative. Don't forget the negative. And that's going to be the fourth term of that. Okay? All right. We're going to stop right there.